Hello everybody, my name is Bhavdeep Patel and I welcome all of you in 11th Science Chemistry Unit number 1, video number 9, and the title is Some Basic Concepts of Chemistry. Today we are going to deal with uncertainty in measurement and some scientific notation. Here, uncertainty in measurement. That is, many times in the study of chemistry, one has to deal with experimental data as well as theoretical calculations. Scientific notation. As chemistry is the study of atoms and molecules, now we know that sometimes we have to deal with larger numbers and smaller numbers. The larger number is nothing but the number of molecules, while the smaller numbers are nothing but the mass of the atoms. It may look funny for a moment to write or count the numbers of 0 involving in these values, and the simplification like addition, subtraction, multiplication or divisions are also become problematic. This problem is solved by using scientific notations, which is represented in the form of n into 10 raised to n. We can write 232.508 as 2.32508 into 10 raised to 2. Moving 2 points from right side to the left side will increase the power 2. Similarly, 0.00016 can also be written as 1.6 into 10 raised to minus 4. As we are moving from left to the right side, the increased power will have negative value. Okay, now let us discuss multiplication and division simplification and addition and subtraction simplification methods. Because here multiplication division rules is same, while here for addition and subtraction the rule is same. So let us discuss first of all multiplication division. Regarding exponential numbers, rules for both the operations, that is for multiplication and division, follow the same rules. Here we have example. The first one is for multiplication. 5.6 is multiplied by 10 raised to 5. And here again we multiply by second bracket 6.9 into 10 raised to 8. Now in the next step we are going to multiply 5.6 with 6.9 in another bracket, while the power of 10 raised to 5 and 10 raised to 8 are going to be added with each other in another bracket. So here multiplication of 5.6 and 6.9 gives us answer this one, while the addition, because whenever the multiplication of exponential power is there, we have to make addition, and when division is there, we have to make subtractions. Now 5 plus 8 is going to convert into 13. You can also write this answer, but if you would like to convert it into such kind of manner, then you have to move one digit from one decimal from right side to the left side, which will increase 10 raised to 1 power. Means 38.64 become 3.864, and 10 raised to 13 power is going to convert it into 10 raised to 14. Here again division is there. 2.7 into 10 raised to minus 3 is divided by 5.5 into 10 raised to minus 4. For that, we are going to make a separate bracket for 2.7 divided by 5.5 is over here, while 10 raised to minus 3 and 10 raised to minus 4 are there. Here the division is there. The division is going to convert it into subtraction. So here 10 raised to minus 3 and this 10 raised to minus 4 when going to become a numerator, it will become 10 raised to plus 4. But when division is there, the symbol is subtraction, minus. So 10 raised to minus 3 minus 10 raised to 4. So it can be written like this. Now division of both this gives you answer 0.4909 by 10 raised to minus 3 minus 4 results into 10 raised to minus 7. Here, if you would like to convert it into 4.909, you have to gain one decimal from left side to the right side. Means 0.49 is going to convert into 4.9. Well, over here, decrease one power. Yes, that is, you came from left to right. 10 raised to minus 7 will become 10 raised to minus 8. You know very well that in minus 7 is larger number than minus 8. Is it? Next, addition and subtraction. For both these operations, first numbers are written in such a way that they have same exponent. Means the power of 10 we have to convert in the same numbers. Then and then we can do addition or subtraction. Here, addition. Two brackets are given to us with the different powers. Here, I am not going to make any kind of change regarding the bracket number 1. While for the bracket number 2, I am going to convert it into 0.895. That means I am going to move from right to the left, which will increase one power. We have already discussed in the earlier case that here 13 is there. We are going to move from right to the left. We will make it one more because we just move a one step. So 13 is going to convert into 14. In the same manner, here 8.95 is going to convert it into 0.895. So 3 is going to become a 4 because we are moving from right to the left. Will increase one power. Now make the addition of both these in a separate bracket and carry out 10 raised to 4 as a common term. Simplifying gives you this answer. Subtraction. Here two different brackets are given to us with the different powers. In the first bracket I am not going to make any kind of change, while for the second bracket I am going to move from right to the left. Yes, right to the left. What does it mean? Right to the left will increase one power. So here power is 10 raised to minus 3 and one more means we have to add 1. So 10 raised to minus 3 plus 1. It gives us answer 10 raised to minus 2. Means both the powers are same, exponents are same. So make it as a common out and do the subtraction of 2.5 minus 0.48. Gives us answer 2.02 into 10 raised to minus 2. So this is all about multiplication, division and addition subtraction relations.
Significant figures. Every experimental measurement has some amount of uncertainty, that is due to the limitation of instrument. If we are using platform balance and weighing out some substance, we got answer 9.4 gram. But if we are going to use analytical balance, which is we are going to use in the laboratory, then we can measure the exact value 9.4213 gram. Significant figures are meaningful digits which are known with certainty plus. Say for example 11.2 ml is our reading. We can say that 11 is certain and 2 is uncertain because uncertainty would be plus or minus 1 in the last digit. There are certain rules for determination of significant figures. Rule number 1. All non-zero digits are significant. Say for example 285 centimeter, 3 digits are there, so 3 is the significant number figure. 0.25 ml, that is here we have just 2 significant figures. Rule number 2. Zeros proceeding to first non-zero digits are non-significant. Say for example 0.03 has one significant figure like 0.0052 having 2 significant figures. Rule number 3. 0 between 2 non-zero digits are significant, that is 2.005, between 2 and 5, two zeros are there, but they are significant. So, total significant numbers are 4. Rule number 4. Zeros at the end or right of a number are significant. That is, 0.200 gram has 3 significant figures because they are on the right hand side. The terminal zeros are not significant if there is a no decimal point. Say for example, 100 has only one significant figure, but if we are writing 100 point, then it has 3, while 100.0 has total 4 significant number. 100 can also be written as 1 into 10 raised to 2. For one significant figure, we can write 1.0 into 10 raised to 2. For two significant figures, we can write 1.00 into 10 raised to 2. For that, three significant figures. Rule number 5. Counting the numbers of object, for example, 2 balls or 20 eggs. Here, infinite significant figures are there. 2 can also be written as 2.000000 or 20 can also be written as 20.000000. If 4.01 into 10 raised to 2, then it has 3 significant figures. And if we are going to write 8.256 into 10 raised to minus 3, then it has 4 significant figures. Precisions refer to the closeness of various measurement for the same quantity, while accuracy is the agreement of particular value. Say for example, the true value of any experiment is 2 gram. When student A takes two measurement and report the result 1.95 gram and 1.93 gram. Here the values are precise as they are close but are not accurate. Student B reports 1.94 and 2.05. Here the two measurements are there, but the observation is like that neither it is precise or accurate. When student C is going to perform the practical, he gives us the measurement reports like 2.01 and 1.99. What does it mean? These values are both precise and accurate because they are more nearly with our true result, that is with 2 gram. In table 1.4, we are given the results of experiments of student A, B and C. From the results, we can say the student C gives us accurate results. Multiplications and division of significant figures. Here 2.5 is multiplied by 1.25 gives us answer 3.125. Since 2.5 has only two significant figures, the result should not have more than two significant figures. So our answer is going to become 3.1 instead of 3.125. Rule number 1. If the rightmost digit to be removed is more than 5, the preceding number is increased by 1.386. 6 is the more higher value than 5. So here we are going to remove 6 and round it up to 1.39. Rule number 2. If the rightmost digit to be removed is less than 5, then no change is there. Say for example 4.334. 4 is smaller than 5. So 4 can be removed easily, but its roundup is going to become 4.33. Rule number 3. If the rightmost digit to be removed is 5, then the preceding number is not changed. It is not changed if it is even number, but it increased by 1 if it is an odd number. 6.35. Here 5 is odd number, so it increased from 3 to 4. While 6.4, here the answer is 6.4. But if 6.25 is there, if we would like to remove 5, then 2 is even number, so we cannot add 1. So our answer is going to become 6.2.
So now let us deal with dimensional analysis. Okay, to understand this topic, we are going to understand 3 examples. The first one ml piece having 3 inch length converted into centimeter. That means you know for what we are going to talking about in this topic, that conversion of one unit into another. Is it? The second case is there. Here liter to meter cube, and the third case is there. This to the second. Means these are the conversations, interconversations. Let us study the first case. One alloy piece having 3 inch length converted into centimeter. Before solving this sum, we have to keep one thing in mind, that 1 inch is equals to 2.54 centimeter. Then 3 inch has how many? Means the cross multiplication is there, is it? And 3 inch into 2.54 centimeter divided by 1 inch. Here both the units are same. One is as a denominator, one is as a numerator, and we are going to cancel out both of them, having the unit of our answer is in centimeter. You have to just multiply both this. Second, one jug contains 2 liters of milk converted into the meter cube. So 1 liter is equals to 1000 centimeter cube, and 2 liter has how much? So here the liter unit are same in numerator and denominator are going to cancel out. So our answer having the unit in centimeter cube. But here we would like to convert it into meter cube. So we have to know one relation, then 1 meter is equals to 100 centimeter. What does it mean? 1 meter over 100 centimeter is equals to 1. How it is? 1 meter is equal to 100 centimeter and 100 centimeter is equal to 1 meter. What does it mean? Both having the answer 1, same. So here to convert it into the cube, I have to make cube of this one. So it is over here. 1 meter, 100 centimeter, whole raised to cube. Simplified 1 meter cube, and here 10 raised to 2. And its cube, 2 3s are 6. Do not make the cube of 2, that is 8. Is it? Here 2 is multiplying by 3. 2 3s are 6 and centimeter cube. Now if we are going to put the values of this like this one, what does it mean? That 100 is over here, make a cube, means 10 raised to 6, and centimeter cube means the whole answer is 1. Here our answer is 2 into 1000 centimeter cube is going to be multiplied by this answer, 1 meter cube over 10 raised to 6 centimeter cube. Multiplying this, we get answer 2 over 10 raised to 3. Because here what does it mean? 10 raised to 3, and here it is 10 raised to 6. 10 raised to 3 is numerator and 10 raised to 6 is denominator. So the 10 raised to 3 power is cancelled out and the remaining is 10 raised to 3. The common units are cancelled out. The unit is meter cube. So 10 raised to 3 is denominator. If one would like to write as a numerator, we have to make minus symbol before that. Third one, 2 days has how many seconds? To convert this, here is the answer. 2 days. 2 days has 2 days. For 2 days, how many hours are there in a day? 24 hours. And how many minutes? 1 hour has 60 minutes. And all this minute has how many seconds each? 60 seconds. So 2 days multiplying by 24 hours multiplying by 60 minutes multiplying by 60 seconds. That is 24 hours per day, 60 minutes per hour, and 60 seconds per minute. Now day and day, hour and hour, minute and minute units are cancelled out. The remaining unit is in second. So 2, 24, 60, 60. When multiplied, we got answer, and the unit of the answer is obtained in the second.